Welcome to today's Explainer. We're taking the official Cambridge Learner Guide and syllabus for 2026 to 2028 and, well, turning it into your ultimate strategic playbook for acing IGCSE physics. Whether you're aiming for a solid pass or shooting for that top A-star grade, having the right strategy is honestly just as important as knowing your formulas.
So let's jump right into the game plan. We'll be covering the IGCSE Physics Playbook, knowing your exam papers, conquering the practical assessments, mastering math and concepts, best practice study strategies, and finally, winning on exam day.
All right, kicking things off with Section 1, the IGCSE Physics Playbook. You know, a lot of students think physics is just this giant memory test of complex equations and rigid facts. But if you look closely at the official Cambridge syllabus, it's not just about memorizing stuff. It's about understanding how to actually play the game. You've got to display the right experimental skills, handle data efficiently, and show the examiners exactly what they want in the precise format they're looking for. Which leads us perfectly into Section 2, knowing your exam papers. Notice how the pathways split here. You don't just sit down for a generic exam. You'll either take the core papers, which cover the easy to medium topics, or the extended track, which adds in that harder supplement material. Bow the core route, that's papers 1, 3, and your practical, and you're eligible for grades C to G. But if you're aiming for the top, you'll tackle the extended route, papers 2, 4, and the practical, targeting grades A star to G. You and your teacher will figure out the best strategic fit for you. Now check out the official assessment objectives. A massive 50% of your grade is pure knowledge and understanding. We're talking your core definitions and concepts. Meanwhile, handling data and problem solving makes up 30%. And those practical experimental skills, they account for the final 20%. Knowing this exact breakdown is absolutely crucial for allocating your revision time perfectly. Okay, let's talk multiple choice questions. The absolute golden rule here is that you must always read the introductory sentences above the diagram before you even think about choosing your answer. I know it's super tempting to just glance at a drawing of a distance-time graph and try to guess the context, but the official examiner's guidance stresses that crucial information is hidden right there in those intro sentences. Seriously, don't fall for the trap of skipping straight to the A, B, C, D options. Now, when you tackle the structured questions in theory papers 3 or 4, the game changes. There are no multiple choice safety nets. And remember, there are no optional sections. You have to answer everything. Do not leave any blanks. If a question asks you to calculate the mass of a metal or describe how to find volume, you have to engage with it. Leaving it blank guarantees 0 marks, but even a partial attempt might grab you some partial credit for your method. It's totally worth a shot.
Moving right along to Section 3, conquering the practical assessments. So, whether you're doing hands-on experiments in a lab for the Paper 5 practical test, or you're taking the written alternative to practical for Paper 6, you are going to face an identical 6-mark question. This question focuses entirely on planning an experiment, like dropping a metal ball into sand to investigate crater size. It's a highly predictable part of the exam, which means you can and absolutely should prep for it heavily. To secure those 6 points, you've got to practice these core skills constantly. Clearly state which variable is being investigated, and just as importantly, which variables you're keeping constant to make it a fair test. You'll need to list any extra apparatus, explain exactly how you take your measurements, and suggest a suitable graph. Oh, and here's a pro tip. Draw simple, fully labeled diagrams if it helps explain your plan. The examiners love that. All right, Section 4, Mastering Math and Concepts. Here is a major misconception trap that examiners absolutely love to test: the difference between mass and weight. Students mix these up all the time. Just remember, mass is a measure of the quantity of matter at rest. It literally doesn't change unless you physically lose matter. Weight, on the other hand, is a gravitational force. Your weight changes based on the gravity acting on you, like if you suddenly teleported to the moon. You need to get this distinction crystal clear. When math meets physics, you need to use this calculation cheat code. Look, if a calculation is worth 3 marks, 2 of those marks are usually just for showing your method. So, Step 1, write the formula. Step 2, show you're working by plugging in the numbers. Step 3, calculate. And Step 4, add the correct unit. Even if you completely fumble the calculator buttons and mess up the final number, you still salvage the points for showing your method. How great is that? The syllabus also demands that you pay attention to details, so you avoid common traps. First, use consistent units.
Convert distance to meters and time to seconds before calculating speed. Second, get comfortable with inverse relationships, like how in electromagnetic waves, as the wavelength gets longer, the frequency gets lower. And finally, there are just some strict facts you have to memorize outright, like the human audible sound spectrum being exactly 20 Hz to 20,000 Hz.
Let's pivot to Section 5, Best Practice Study Strategies.
The Learner Guide puts a massive emphasis on command words. Highlighting and understanding these exact words in past papers is honestly the #1 hack for giving examiners what they want. If a question says describe, it just wants a factual account. But if it says explain, you've got to provide reasons and use physics principles. Treating those two words as if they mean the same thing is a surefire way to bleed marks.
We want to study smarter, not just harder. The official guide actually recommends working in short bursts with active recall rather than just zoning out while reading a textbook. Make your own glossary of key terms, and hey, when you define them, don't use the word itself in the definition. Try redrawing simple, fully labeled diagrams from memory. And honestly, one of the most powerful things you can do is dissect old mark schemes so you can peek behind the curtain and see exactly how points are awarded.
And finally, Section 6, winning on exam day. This might sound obvious, but time management is where so many students drop the ball. Look closely at the mark allocation to dictate your pacing. A 3-mark question requires way less time and a much shorter answer than a 10-mark question. Don't write a novel for 2 marks, right? But on the flip side, don't just drop a brief sentence if the question is worth 5. Let the marks be your guide.
In the heat of the moment, you've got to keep these execution hacks in mind. For multiple choice, never guess answers based on imaginary patterns. There is no secret ABCD code to crack. For math questions, always do a sensible check. If you calculate the speed of a normal car to be 3 million meters per second, yeah, you've made a mistake. Ask yourself if the number actually makes physical sense. Also, use a really sharp pencil for graphing to get thin, accurate lines. And please, make sure you answer the specific question asked, rather than just word vomiting everything you know about the general topic. I really want to highlight this official guidance directly from Cambridge. It basically proves that for theory papers, quality triumphs over quantity every single time. The examiner doesn't want to dig through a messy, rambling paragraph just to find a single correct keyword. Be direct, use proper physics terminology, and structure your thoughts clearly. So, you now have the ultimate strategic playbook straight from the source. You know how the papers are built, what the examiners want, and where the common traps are hiding. But honestly, having the playbook is only step 1. The real question is, now that you know exactly how the examiners think, what will you change about your study routine today to ensure you beat them at their own game?